So I'm going to, before I get started on what's going on here, I'm going to show you in your textbook, kind of, because they overlap their graphs, and I'll show you what they're trying to do. So I'll do the textbook first, and then I'll come back to say, hey, what's the heck is going on here? Actually, this is a all right, so looking at this, you might not be able to see, there are different colors. Red, black, and blue. And it even indicates, you know, that's the pink or red, and that's the blue, and the down here is the bottom. That's the original. So you guys should know the original y equals x squared is a parabola. You should know that that's definitely a parabola. And you should have an indication that it goes up. Now, today will probably be your first reminder when it goes up and when it goes down, because that's the only way your parabola is to be a function, can stay a function. Parabolas going left and right are not even functions. And then in chapter 2, there will be a specific section on parabolas, which is called quadratic functions, Anyway, for today, we're going to be given, I call it the base function. This, they even say here, hey, look at the graph of x squared, just base function x squared. Or look at the graph of f of x equals absolute value of x, base function. Or look at the graph of y equals square root of x, the base function. And then what happens here in comparison there? What happens to that in the picture of that equation right there in comparison to that? Well, as I said, if you had no calculator and you did a table of values and you made a table of values for this and you plotted 1, 2, 3 points, you can do that. Plot the points and you'll get an idea that, hey, this thing looks like this. Okay, you should also have a sense of what this looks like from your intermediate algebra class, because that, I repeat myself a lot, Bonnie. It's my assumption that you have basic ideas of all the topics that I'm showing you in this course. We just get deeper and I elaborate it, and you just have to be reminded. I'm not like how to graph this. I don't teach you that. You should know how to do that. The concepts that connect these two, that's what I'm going to teach you. How to graph that, I shouldn't have to tell you how to graph that calculator. That's the easiest way. Or make a stinking table of values. It's the connection language-wise. How do you go from here to there? What does this look like in comparison to the original base function? And you can see some words right here. Shift 5 units left. Subtract 5 from each coordinate. And I'll show you how that works with a crazy picture that I have shown you guys so far this semester. I've shown you the same picture. And you'll know what I'm talking about when I get there. Anyway, so, gosh, let's see. Can you graph that one? Of course you can. So I'm not going to ask you to graph these pictures. I'm going to ask you in words so that your answers are that, the first sentence, shift 5 units left. There's a shift left, right, up, and down. There's a reflection. There's 2 axes that they talk about reflection. That's called the x-axis reflection. And that one's called the y-axis reflection, if you can see my picture, what I'm doing. My screen, me. And then there's what's called a shrink and a stretch. There's both a vertical is up and down, vertical shrink and vertical stretch. What does that look like? And there's a horizontal shrink and stretch as well. So there's a lot going on in this section. but I've tried to compact it down so it makes a little more sense for you guys. I'm hoping. And then I'll explain what to expect on, say, the quizzes and exams coming down the road. I'll do that as well. Okay, so let's. The language. Yep, that's what I'm going to test you on basically is the language. On the exam, I could give you a picture. That's an idea. I could give you a picture of something, an image. And the question would be multiple choice. Find the correct function that would produce the picture you see. Not a hard problem. All you do is just, well, all you could do is one at a time, put in the equation in your calculator in the appropriate screen, window screen. We've done these before too. Window screen. Right there, window screen. You'll see on your picture how far left, how far right. That's the X-min and X-max on your calculator. That the picture is shown on the test, and how far up, down, and how far up. So you can set up your screen first before you hit graph. So you can match up what the picture is supposed to look like. And it's one at a time. It might end up being letter D. So it might take you a little time and you can narrow it down. That's pretty easy. I wouldn't give you very many of those because that's too easy of a problem. It would be more like describe in words what I'm about ready to show you. And so you just got to know when to use left, right, and when to use reflect. And by the way, it's a reflect about x-axis. Now the reflect around the y-axis, I will not do, and I will not hold you accountable. There's just a lot going on, and I've chosen two things not to have you do homework on, nor to hold you responsible. And you can figure out those ideas in, let's say, your calculus class, should you need it. I'm giving you most of it, most of the idea. Vertical stretch and vertical shrink. I'm not doing the horizontal stretch and horizontal shrink. So I'll tell you what I'm not doing. Reflect about y-axis. And I'm not doing horizontal shrink and stretch. Not doing those. Finally, up and down. Now, it's important to note that I didn't do these just randomly and say number 1, 2, 3, 4. It has to be in this order. Has to be. If you verbalize, and I'll put on the multiple choice, I'll mix all these things up. I mean, the right answer might be there, but in the wrong order. Order is important, just like in PEMDAS. It's the same thing here. So you have to give me the left and right first statement. And if there's any up and down, it has to be the last thing you do. Has to be. And I have down here number 2, the reflect, whatever that is, reflect around the x-axis. There'll be some symmetry that you'll see with respect to that. And then the vertical stretch and shrink is number 3. It turns out, in reality, 2 and 3 could be interchanged. To produce the graph by hand, if you did vertical stretch and shrink first, whatever that means, and then you do the reflect, you'll get the same thing. You get the same picture. So if you say, Jeff, I just want to know, I want to know what's first, second, third, and fourth. Well, there you go. That works perfectly fine with me. Never do up, down first when there's a left, right. Never do an up, down first. If there's a vertical stretch or shrink, whatever that is, you always do that last, always. All right, so I'll just do that one in order. I mean, I'll do that by hand. Label your axes. Okay, that means X and Y. There's your axes. Let's see if I make a little table of values like this. Here's your X, here's your Y. So we go over here and let X be 0. You get 0. Let X be, let's say, -1. That's +1, as well as when X is 1, it's +1. These are ordered pairs. So put in a -1 and square both the negative and the 1. You get a +1. That's what I'm showing right here. And how about -2 and +2? You get the same thing. So 0, 0. So in your textbook, had I had you do the homework based on the author's instructions, you would have to do, for every problem, you'd have to redraw or draw the base function like this by hand. And then you'd have to draw ordered pairs. Now, you could get the ordered pairs from your table of values in your calculator. I get that, and that's okay. If you didn't do it like in your head, that's all right, but you'd have to draw each problem. And when I say each problem, I'm going to peek over here for a second. Peek. Yeah, so if I look at that one and drew it and wrote it over here, g of x. So in your textbook, it'll say, well, draw that, and draw that. So if I drew this and I used my calculator and used ordered pairs in the table instead of by hand, and I put that in, so x squared Now, the nice thing about parabolas, there's so much symmetry going on. What I think I'm going to do is look for the y's that match up. Okay, these y's match up right here and here. Oh yeah, well, there they are. The first 5 right there. Those are nice. So I think that's what I'm going to do is I'm going to plot -2, 1. So if I did this, and if you were asked to on the homework, it says make sure you display your order, your table of values. Make sure you do that. You would just copy this down, x and g of x. And as I said, I'm just going to pick the top 5. I think most of you know that right there is going to be called the vertex. And in chapter 2, as I said, we're going to come back and revisit this in great detail about vertex, the line of symmetry, and a few other items from your intermediate algebra class when you first looked at it. Okay, I'm plotting that. Now I'm going to plot it in blue or purple, whatever this thing is. So -2, 1. So -1, 2, 1. -1, -2. So -1, -2. And 0, -3. 1, -2. And And then you connect the dots and you go like this. And for the homework, that's what you would do. And you'd be done and move on to the next problem. So as I say, it would be easy for you to produce the graph by a calculator and just plot the points. It's not like a lot of algebra work to me. And just to show you, there is a way of checking your work. So if you end up going over here and did x squared, and you graph both of them on that Zoom standard, which is a 10 by 10. That's the, yeah, see, it looks just like what I did. Okay, I feel happy, then I move on to the next problem. So if I'm not having you necessarily do any of that graphing stuff, what am I asking you to do? It's the language. And here we go. So I'm not going to graph anything. From here on out, if I want to select something, which you'll see the kind of crazy problem that I'll give you a peek, a little preview. Okay, see this right here? That's the one we're going to mess around with. This is going to be a group quiz, definitely question, absolutely. On the actual exam, I have to think about how I create a multiple choice test based on this. And I can do that. But right now, we just want to know, how do we do the language right now? So forget the graph. And we're basing the next few on is f of x equals x squared. That's what we're basing it on. And it might even be helpful if I knew that the feature on this is the power function. It's like a polynomial. It's the degree. So I'm going to put parentheses around this. The other functions that are kind of the base functions would look like this: the square root, the cubic, the absolute value, 1 over x. Later on, it'll be, say, e to the x, or you could have a to the x. Those are exponential functions. You can have a log function. You will have a log function, log, base a of x. That's a base function. Even further in the, and that's it for you guys. I'll just stop right there. There are others. When you take your Math 58 class, you'll have all the log functions that would be called, what I do in my Math 27, those are also added to the pile right here. They get them all. You only get, for you guys, yeah, I think these are the most basic ones that you'll have. So if I put parentheses around this, to me, there's a reason. So see how the nature of this is the power. The nature of this is the square root. So I put parentheses around the x. Again, parentheses around the x, parentheses around the x, parentheses around the x, and so on. That's what I do to help me out, and that's already got the parentheses. Now, the first thing that you were asked to consider is the left-right. Where the left-right appears is inside the parentheses I just drew. Where the left-right appears is whatever is, or if there's anything else happening inside here, it's going to be a left or right somehow. If there's anything inside there, when I say anything, it's like add, subtract, inside. I'll show you a peek. Like here. You see how inside or underneath the radical, there's an x minus 2. This used to be parentheses right here. This used to be a parentheses, but inside there's an x minus 2. There's a left-right thing going on in here because it's underneath, inside the parentheses. That is not a left-right. That subtract 1 is not a left-right. No, it's what's, in terms of the square root, it's what's underneath or inside. That 3 is not part of the left-right concept. Nope. So because that 3 is outside the parentheses, that is not left and right. It's not. So what is it? Well, you can see, I told you it's down. So up or down, up or down? The question is up or down, which one? Why is this down? Because it's subtracting. That's easy. The up and down, you just follow the sign. So subtract 3, down 3. I took the red and the blue went down. Okay, now if it's going down, you're affecting all the y values only, not the x's. So going down means you subtract 3 from every y value. So subtract 3 from 0 and you get -3 right there. Subtract 3 from 1, you should get -1 somewhere, which is not shown because I didn't plot that point, and so on. Subtract 3 from 4. Let's see, that would be 1. Okay, there it is right there. So -2 comma 1. So the x's don't get affected, the y's only. Okay, so, and like this one, that's an up by 4 units because you're adding 4. Forget the graphs. It's asking you, okay, compare that and give me the words, take this, and then give me the phrase. Multiple choice question. I'd probably give you something a little more complicated this, but let's say this was the problem. Give me the transformation, parentheses, like as if there's more than one possible, in order. So because you know there's probably only one, I would give you, and I don't need the vertical. I just emphasize that because if you're going down, it's vertical. So if you said, and you picked letter A, shift down 3 units, you'd pick the right one. But letter B might be shift up 3 units. Well, that's wrong. Letter C might be shift left 3 units. Nope. Right 3 units. Nope. Reflect. No. Shrink. Nope, 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 nope. So there's only one answer, which is this right here. Most of these I've already given you the answer. Matter of fact, I think they all so far. Forget the graph, forget the graph. Okay, now because, as I said before, if it's inside this parentheses thing, what parentheses? Okay, so if I had f of x was equal to, again, the x squared. If anything's happening inside the parentheses, which it is, then that's a left-right. Now here's where it becomes a little, I'll call it reverse thinking. It's not what you would expect, unless you remember it follows exactly the same thing as when you graphed parabolas. When you did your intermediate algebra class, which all instructors do this here at SRJC anyway. When they do an intermediate algebra class, they'll take a function that might look like this. And they'll say, hey, figure out the vertex on that. Well, if I did that one, it would be easy because I just used the calculator. There's an algebra feature too that you'll be reminded about how to find the vertex. Anyway, can you tell the vertex from here? No, I have no clue without the calculator's aid or without some algebra. Here's the other form. So this is called standard form with some numbers in there. And this is called standard form, different form. This tells you immediately the vertex. In your intermediate algebra class, you get tested on it. You're shown that. Hopefully you got the idea. And then when it goes to chapter 2 for us, you'll sort of be reminded about it again, because we'll go back over again. Anyway, to remind you, you always you switch the sign of the number that's inside here. So instead of -4, it's +4. The vertex, V for vertex, would be +4. And whatever's on the outside, you keep the sign. K, it's like keep, K for keep. Bonnie, I don't know about your class, because I don't think you took my 155, did you, Bonnie?
No, I took Math 25 and Math 58 from you.
Okay. So, but you would remember this from Math 25 in your time back, but I'm 155 would look at this as A parentheses X minus H quantity squared plus K. That's called a standard form of a parabola, one of the standard forms. So anytime we use, I use like the author does, K, I say K for keep. It's a memory device. So whatever's outside, keep the sign. So +7. All right, well, I have no memory device with the H. You just have to remember, reverse the sign or change the sign or whatever. Whatever's in here, like what's there, it's always the opposite. So +4 is the vertex. And if you say, Jeff, I don't believe you, good for you. Don't believe me. Here, watch. Watch. I'm gonna do this one here. So I claim on this one here, that's the vertex. That's in quadrant 1. That's in quadrant 1. And I also claim I know what the parabola does. It goes up. And that's because there's a 1 right here. And it's a positive. And positive goes up. And now some of you say, oh yeah, I remember now. Thanks for the reminder. So I know it goes up. It's in quadrant 1. Let's hit graph. There it is. And define the vertex, you go second calc. It's the minimum. You guys are remembering that now, because your last section you had to decide for intervals increasing, decreasing. You have to use minimums or valleys here in the, say, -1 and 9. Okay, and then we also in this class, we know what the calculator is trying to say. You know that. We talked about that if you were here last time. That is not the X value and putting the 2.7 at the end. You do that, you're wrong. The calculator is weird, and sometimes it doesn't give you what it's supposed to be, which is actually supposed to be 4. Well, there it is, 4,7. So it's the same thing here. If you're trying to describe this, it's always the opposite sign inside the parentheses. So this is going to be right 2, not left, right 2. Oh, there it is right here, right 2. Excuse me one second. And in like manner, that's a left 2, left 2. I said wrong, not 2, left 1. And this is a combination of the two. So who's first? Left, right. Got to be the one. Who's first? That one's first, that's second. So opposite and keep. So negative means goes down. So on the test, you know, this, I know I've got at least one on the test ready to go that has multiple choice answers that are like this, and they're just all mixed up, and there's only one correct order. Okay, graphing that. I said technology. This is easy, 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 easy. Okay, there's your square root of x. Now, the negative on the outside, we call that reflection. So what'll happen is when I put that in the calculator, it'll go like this. It'll be reflect about the x-axis, so that'll be flipped around. And if you want to see for sure, you just go y equals here, negative x squared of x. Yep. Okay, Jeff, I get that. Yep. So anytime there's a negative, like this one's reflect as well. But there's something extra here. So there's two things going on. Two things, and you have to do the right before the reflect. So, and if you just say reflect, like on the group quiz, you say reflect, that's it, I won't give you credit because I have to have the axis, because there's a reflect about the x-axis and there's also a choice, but we're not going to be, I guess, working those out, but there are two, and I want you to make sure you know that there are two. You have to say x-axis. If you don't, you just say reflect, not good enough. And here there's three things going on. Okay, so inside is always first, outside is always last. So what the heck is that 3 doing? You can think of it this way. Here's the original up here. F of x equals x. So if I went down here and say, well, if f of x equals x, excuse me, square root of x, and let's say all I have is not the 2 and the -1. Let's say I have a different function, w of x is equal to 3 f of x. I said 3 f of x, that's what it is. And f of x is a fancy way of saying a particular letter, and you guys know that's the letter y. So what the 3 is doing is multiplying itself to the letter y. All the y values are tripled in the original. That's how you would sort of plot the points. Here, I'll show you. If this one here was x, and this is f of x, and so if I put in a 0, what if I put in -1? And then 1 and 2, stop right there. What's f of -1? Anybody? F of -1. Unmute your microphone, and if anybody knows, what's f of -1? What's the square root of -1? Anybody in our class so far?
1.
Okay, I'm hearing someone say 1. Okay, I'm square root of -1. I heard someone say something different.
I.
You what? You? I?
Imaginary. I.
I'm messing with you. Now, okay, and here's another square root of -1. I don't know. I don't know yet. So I'd say in this course, it could be that. Because I'm not going to guarantee, it's possible that some instructors in a 155 class, they don't have time to investigate the imaginary number set. I do, but it's not required, it's optional. So I'm going to say for everybody, it's I don't know, undefined, or not a real number. That's probably better. It is defined, we just don't know what it is. Whoever said I, good for you. You have some background knowledge, and this one is not right. And you can say, but Jeff, I was taught that, and I'll say, well, let's see. Then the calculator should also give you 1. And it gives you, nope, it says not real, whatever not real is. Yeah, so it's not 1. So I can't, this would be empty. And if I put in 0, wouldn't that be 0? This could be ERROR in the calculator table of values. I'm gonna check that in a second. This is 1, and square root of 2 is something weird. So let's make that a 4 to make it nice. So instead of 2, let's make that a 4. Now, W, so what I'm saying is, all I have to do is multiply all the Y values that are over here. This is Y by 3. Leave the X values alone. So 0, okay, -1 should still be ERROR, and 1 and 4. So the Y values, multiply this by 3, by 3, by 3. If I plotted this right here on the original, that would be here, here, and 4, 2. And if I plot these guys with blue, I'd have here, here, and here. That's 3, 4, 5, 6. And to prove to you one more time that what I'm saying could be true, Y equals, yeah, like that one. I'm going to go this one, clear that out. 3 root x. Yep, looks like what I did by hand. If I did a table of values, yeah, you can see all the error crap that's in there. That means it's not real. Okay, I'm hoping I'm convincing you. I'm hoping I've convinced you. Absolute value, got it. Oh, by the way, this 3 right here, this 3 right here, that's called, oh, what happens here? We call the blue stretched. It's like you took this and stretched it this way, which is a vertical stretch. Vertical stretch. No horizontal stretch. We're not talking about this way, just a vertical stretch. So this right here, instead of a number bigger than 3, a number smaller than 3 that's a fraction is a shrink. It'll make the graph go closer to the x-axis. It's like a vertical shrink.
Jeff,
So that's, yes, go ahead.
on the previous problem, the r of x equals 3 square root of x plus 2 minus 1.
Yeah, let's do this. You're wanting the what order? Let's do that, maybe. Is that what your question was? I didn't do the order.
Yeah, pretty much what the 2 and the negative and the minus 1 was going to do to the.
So Devin, what would you suggest? What would you say the first step is supposed to be stated as?
Oh boy. Well, it doesn't shift right or left, so.
No, it does.
Oh, it does. Oh, that's right, because of the 2.
Right.
So
Correct.
if left 2, left
Correct.
2.
That you're good. That's good. Left 2. Okay, that's the first step. Okay, between the 3 and the 1, which is the next step?
That is going to be the. Oh, that's going to be the 3. No.
No, you're right. That's right. It is going to be the 3.
Oh, because it's going to be a vertical shrink or vertical stretch up.
Yes. VER vertical STREPCH. That's good enough for me. You could say by 3. I don't need it. So vertical stretch. You said up. It turns out it could be whatever the picture looks like. It could be taking the picture and going, that's a stretch. It's not just having to take, I can't do this. If my finger right here is stationary and then that stretch, because our last problem kept the origin alone. If there was something else, it could go like this. It's a stretch up and down. It's a possibility it goes up and down
I see what you're saying.
at the same time.
Okay.
So just say vertical stretch. It's good.
Okay. Okay.
And then the last one is the one. Is it up or down on the one?
Down.
Correct. Good job. Yeah, it takes a few times to do this, and pretty soon that you get the idea. And if you want to practice with Bonnie. She'll give you a bunch of problems. She can just create things in her head. I know you can, Bonnie, and then know what the answers are supposed to be. Not that hard for you, Devin, to say, once you get it, you'll get it. It just, today's brand new, and over the weekend, it'll be, I think, a little clearer. Now, you could say, Jeff, why couldn't I just do left? Okay, I get it, Jeff, vertical stretch instead of horizontal. Left, vertical stretch, and down. Why do you need the numbers? I think it's going to be helpful, and even right here, you might say by 3. So if I put the numbers in, it's going to be helpful on the big problem that's coming up here in about 5 minutes. So something about the numbers are going to be important. So let's put the 3 in there and down 1. And I'll show you when we get to the bigger one why it's so important. So, Jeff, does it mean that I have to put that on? Is that you could or you don't have to for me? Vertical stretch is probably on the answer key. Multiple choice is all there is. You don't have to say, he didn't put the 3 in there, so it must be, no. But emphasizing the 3 will be helpful in a moment. I think I put no, I did. Left with the number and right with the number every single time. I know I do. Okay, so back over here, because if the I'll call it like the numerical coefficient. The number out here in front is less than 1, bigger than 0. If it's a fraction, it's a shrink. And then if it's a stretch, it's a number bigger than 1. All of what I'm doing is in a nice table at the end of 1.6. Here it is, page 238. Page 238. At the bottom, right here. All the information you need is right there, but it's in the mathematical jargon, so to speak. Okay, out of these choices, 2 of them, or something you're not included. The horizontal stretching and shrinking, we don't do. So if you're going to make a note on your page, you'd asterisk that and say, Jeff says we're not doing that. Okay, what else are we? Okay, in this one right here, reflection about the y-axis, we're not doing. So if you asterisk that one and that one, say we're not doing, or reverse it, asterisk the ones where we are doing, which are the other ones, then maybe here you're going to see, okay, vertical shift is like up and down, 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 up and down. Raise lower, up and down, up and down. See how the numbers are outside the original, where left and right here is inside the parentheses kind of thing. So this is left and right, left and right. And it's going to be key that you say, hey, I'm going to add something to the y values. See, f of x is y, and add that number, or subtract it from the y values. Over here, what you're doing is you're adding something to the x, subtracting something from the x. The only thing that affects the x when we start doing the next problem or two is the left and right. Everything else affects the y. Affects, effects. Gosh, my English is, it's going to change. Which one is it? A or E, you English majors? Affects or effects? It changes something. All right, nobody knows, so I'm going to put effects. It may not be right. Effects.
Yeah, effect is a verb, affect is an adjective. So if it changes, it would be effects.
Thanks, Devin, for confirming my guess. It was like a flip of the coin. Thank you for that, though. Makes sense. Verb is an action word. I remember now my English. Yeah, thank you. Okay, all of these effects. So if it affects the x, you're either adding or subtracting. You're never multiplying the x. Here, you're the ones I'm going to give you. If it's affecting the y, the reflect is multiplying. The reflect is the negative sign, so it's like you're multiplying by -1. The vertical stretch and shrink affects the y by multiplying again. So these two are multiplying the y value, and up and down you add, subtract the y from the y value or to the y value. So if this affects the x, you're either adding or subtracting a number from the x value, and that's the first thing you do. And then all the rest of the stuff affects the y value at the end, and then you plot your points. I'm going to show you how to do that with 1 or 2 problems, and then we're going to stop there for today, and maybe Bonnie can do a few of these in her session today if she would do that. Okay, I'm going to do 2 of the ones. And you do have a little quiz today as well, little quiz number 3 that I saw. So I'm going to do this one. So flip the page. I'm not doing the ones that lead up to this. I'm just doing this one because I'm going to do something to the x and something to the y on this one. This is my suggestion that you do. This is the same graph we've used before in the past. I'm first going to identify the key points, A, B, C, D, E, F. And I'm going to renumber those, I guess, using my information here so that I have 6 new points, and I can plot those and connect the dots because they're just lines. And then the picture will reflect what happens here, how this affects the graph. You have no way of checking it. See, this one's a nice one because you can't put whatever this is in your calculator and come up with the result. You can't do it. So, and your textbook has a couple, 2 or 3 of these as well. All right, so this one here, I think we agreed that this was -3, comma 1, 2, 3, 4. And this is -1, comma -2. And this was 5, comma 7. And this was 8, comma 7. And this was 8, comma 3. And this was 12, comma 6. So if I thought about this, this is a left 3. Means subtract. Yeah, because left means subtract. Subtract 3 from all the x values. And so what I'm going to do is right above these, because it's easier, I think, for me and you maybe to see as well. I'm just going to do all the x's first. So right above in red, I'm going to do the arithmetic in my head and write down the result of the x's. So subtracting, let's see, left 3, subtracting 3 from -3 gives me -6. Okay, so -1 subtract 3. So remember, this is left, so I'm subtracting. So -1, so that's -4. I'm subtracting 3. 5 subtract 3 is 2. 8 subtract 3 is 5. And 5. And 12 subtract 3 is 9. Okay, now the next thing right here is the 2. And now you go the direction that you see, meaning it's going down 2. So that means subtracting 2 from the y's. So this would be down 2. So that means subtract 2 from y values. Subtract 2. Okay, so go back up to up here the y. The original y is in blue. So subtract 2 gives me 2. Okay, this is a little harder in your head. -2 subtract 2 is -4. So got to be careful of that. And if you need to, just use your calculator. You type in -2 subtract 2 and hit enter. Don't have to trust your mind because sometimes I daydream and I screw it up. 7 subtract 2. 3 subtract 2, and 6 subtract 2. So all my red, I'm going to plot in red. So negative, now I couldn't find, this came off the computer. This image right here turned out to be a really nice image that came out really not fuzzy, or it came out really nice. So I liked it. I couldn't, or I didn't have time to create the axis to emulate the origin being over here. So understand that when I plot this, there's a shift of left and down. So it's like I'm taking that B and I'm going left and down. The B is down here somewhere. And everything else is the same idea. So 1, 2, 3, 4, 5, 6, and 2. And don't forget, open circle is a 2. That's your new A. Okay, B is -4, comma -2. 1, 2, 3, 4. 1, 2.
Wouldn't it be -4, -4? -2 minus 2 is -4?
See, I get to talking, and I even just said I'll make a mistake, and I do it in my head. Thank you. You're right. So if I'm subtracting 2 from everything, I think I did that one, that one, that one, that one, that one. I didn't do this one. And this needs to be -4. So thanks for stopping me. That'll change this one here, of course. So -4, comma -4. So -4, -2. And then connect the dots. So you connect the dots. Okay, C is, the new C is 2, comma 5. 1, 2, 3, 4, 5. And that's a solid dot. Connect the dots. D, 5, 5. 3, 4, 5, 5, 5. E, 5, 1. That's an open circle. So this is B, this is C, this is D, this is E, and then finally 9, 4. So let's see, that's 5, 6, 7, 8, 9, 1, 2, 3, 4. And then so that's how that works. Okay, the last one I'll do. Let's see what's different. I chose this one because I think there was a, okay, that one would be multiplying all the y values by -1. See the negative right there? There's like a -1. I'm not going to do that one. Let Bonnie do that one. That's a reflect around the x-axis. That should take this and turn all this above, down below, take that little v, put it above. That's what'll happen if you do it right. Okay, this one's got a 2 out there and a 4 there. Okay, which one is first? It's got to be the 4 because that's the left, right, and it's always opposite. So that's a left 4. So this is a left 4. That means subtract 4 from x. And the 2 is a vertical stretch. So vertical, S-T-R-E-T-C-H, by, if you want to say by 2, that means you're going to multiply, because it's multiplying right here. Multiply the y's by 2. So there's movement of this to the left, and then all of a sudden the A, the B, the C, the D, they all get stretched somehow. So this is your X, this is your Y. Back over here, the ordered pairs was -3, +4. 1, 2, 4. Okay, in red. So the X subtract, I'll do the X's first. Subtract 4. Subtract 4. All right, now we're multiplying by 2 all the y's. So multiply 4 by 2, 8. -2 times 2 is -4. Multiply by 2, 14. 14. Multiply by 4, 12. Hold on a second. I'm going way too fast. Multiply by 2. Okay, gosh darn it. Okay, multiply by 2. That's good. That's good. That's good. 2 times 4. This is weird. Crazy. Multiply by 2, 6. Multiply by 2, 12. Okay, I think I fixed it. Okay, now in red. -7. 1, 2, 3, 4, 5, 6, 7, and +8. 2, 3, 4, 5, 6, 7, 8. Open circle. -5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Dot. 114. Okay, I'm going to be off my screen, but that's okay. Off my graph. 1. Okay, that's 10, 11, 12, 13, 14. Somewhere up here. So this is your A, this is your B, this is your C. Okay, 414. 2, 3, 4. Here. B, 4, 6. So 4, 1, 2, 3, 4, 5, 6. E, and 8, 12. So let's see, 4, 5, 6, 7, 8. Gosh darn it. 4, 5, 6, 7. 4, 5, 6, 7, 8 right here. Okay, 8 and 12. That's 10, 11, 12. Okay. And this is all being recorded, so you can go back and take a look at it and re-watch it. All right. So let me tell you your little quiz. I'm going to take a look at it and remind you, it's not on today's material. Nope, 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 not on today's material. You guys are math 25. Yeah, by what I'm seeing in my course, I know what my plans are. It should be 1.3. That's the kinds of problems be out of 1.3. Let's take a look here at assignments. 3. Before I release it, I'm just going to double check. I see question even, odd, neither. I see piecewise, increasing, decreasing, difference quotient, something about symmetry. Yeah, everything's out of that 1.3. I see 6 problems. 6 problems. Okay, I'm going to go ahead and publish that and see if you guys see it in your, you see that in your Canvas. It's number 3, daily quiz number 3. I just need a couple of you to thumbs up or shake your head like this. Yes, I see one. Okay. So you're going to go in your little quiz. We've done this twice. So I'll put you in groups, let the machine, I think I'll put you in 3. Having more of you helps, and because of time, I'd like to get you over to Bonnie with some extra time possible so that she can answer and do a few more of those problems for you today. So when you're done, head on over to Bonnie. I'll be out here back and forth getting a cup of coffee. If you need me, holler for me. Hey, Jeff, are you there? Because I'm around. Okay. I'm around until, I'll say until 10:30. Then I've got a class ready to go. So.
Did you want to check in today, Jeff?
One more time.
Did you want to check in? You said you had something you wanted to talk to me about, I think.
Yes. So I'm going to let me put them in groups, and then I'll tell you. Okay. It looks like groups of 4 and one group of 3. Okay. Farbod, you find the invitation to?
Yes, I'm trying to find our quiz for today.
Okay. Look under Canvas assignments.
Yes, I have group quiz 1 is
No, it'll be daily quiz number 3 is what you're hopefully.
Okay, I see it. Thank you.
Okay, you're welcome. Yep. If you wouldn't mind, on days that I say daily quiz, send me a list. This is what I was brainstorming with Jan too, and we'll try it. Send me a list of those that were not in attendance rather than in attendance, not in attendance. And the reason is, once I start this process, I'm going to tell my students, most of them are not figuring this thing out, that my daily quiz I don't put a timer on it. Meaning any student that is absent today, they can go in and go ahead and take the little daily quiz without being here. My intent is they take the daily quiz when they're here. I don't want them just being absent. It'll be one of their throwaways if they're not here. So if I know for right now, until I can put timers on everything, who wasn't here, and if they end up taking the quiz after I've put out the word, it's not going to count, then I'm going to go back and change theirs to a 0 and explain to them again, you have to be here in order to get a score. So I'm just going to try it on days, and you won't know when well, I guess I could send you. Did I send you an assignment sheet that shows when I'm scheduling the daily quiz? Okay, you're muted. That's okay.
I just noticed that. Yeah, it's got that little pop-up that says, you're muted. Yeah, you did send me that. I have to say, I don't check it every single day before class, but I have the information available to me.
Okay, so.
I've also noticed it tends to be once you've finished up a section rather than in the middle of a section.
That's true. And then most of the times I will not have, let's say, I split up a section in 2 days. I won't do it on that. But most of the time, it's just one section per day. But I think you'll see when I've got them scheduled. That's all I'm asking is on those days,
Yes, I
and
do have them.
send me who wasn't there, and I'll put it on myself whether I do something with it or not.
Do you want an email form
In
then?
an email. Yeah, in an email.
Okay. I don't know if you know who's dropped, but there's a couple students that haven't shown up since the very first day. So I'm assuming that they've dropped.
Good question. You know what? I'm just going to go. I've got you right now while they're in their room. I'm going to check my portal and see the total number I've got.
I've got 5 suspects for drops, or at least they haven't been showing up. So
View rosters. Well, it shows 29. Okay, let me look under manage rosters here.
yeah, that's right, because we had 34.
Let's see.
At least I have 34 roll numbers.
We did. I showed 29. So 29, you want to know, you want to give me a name, suspect, and I can tell you if they're on this list?
Barbosa,
Not here.
Bertacci,
Still on my roster.
Gordon,
Not here.
and Madsen,
Not here.
and Martinez.
Not here. So the Bertacci is still listed, whether it's a she, I think it's a she, Cheyenne or something. I'm assuming female. May have not figured out how to drop and it's just going to hang on and they're going to get an F. I just as me as an instructor, I don't know how you approached it when you were teaching. I figured
I had 11 students, so I didn't encounter that.
big boys, big girls, they're
Uh-huh.
responsible. I don't drop anybody. And if at the end they didn't drop and they're past the deadline, then they get an F and they have to figure out how to change that. They have rights to petition, but it's a pain in the ass.
Mhm.
So I don't go through, I have an opportunity to drop people in my census. I just don't do it. So anyway, that's me. Yeah, we're at 28. It sounds like that are maybe showing up. And I don't know how many showed up today. Let's see, how many rooms? I forget
I
how
took
many.
a roll. We only had one person who's regularly here that was absent today.
I think we only had 23, 24, 23, not counting you. I can see how many rooms I got. And 1, 2, 3, 6 rooms. 6 times 4 is 24, but one has a 3. Yeah, there's only 23 that showed up today. Isn't that interesting?
Well, let me count my numbers then. 1, 2, 3, 4.
Oh, I'm going to
5,
stop recording, by the way.